Next up will be Stan Williams. He has worked for ERGON Asphalt and Emulsions for 6 years as the technical marketing manager for Arkansas, Louisiana, and Mississippi. Stan obtained his BS in civil engineering and MBA from Mississippi State University.
Thank you for allowing me to be a part of this presentation. I can't believe that I would say I'd rather be given a live in-person presentation, but I really wish we were through all of this social distancing stuff so that we could be together. But today I'm going to talk about scrub seal best practices. If you don't know what a scrub seal is, I imagine in a group with 190 people or so in it, but there's probably a few people that have never heard the term. That's okay. If you're familiar with a chip seal, then a scrub seal is going to be very familiar to you. A scrub seal and a chip seal are very similar. They're both treatments where an asphalt distributor is used to just spray a layer of asphalt on the road, and then a chip spreader comes along and drops an aggregate down. That way that asphalt is used to seal off the road and provide a new driving surface if that's what you need. They're both very similar like that, but there are a few differences. And the first difference, as Chris was talking about, is that a scrub seal uses a polymer modified rejuvenating emulsion instead of like a chip seal that normally uses a rapid set emulsion. The second thing, as you can kind of see up here in this picture, the asphalt distributor is is pulling a broom sled, and that's where we get the name from. This sled is used to carry a wave of emulsion, and it scrubs that emulsion down into the surface cracks in the pavement. If you've got a cracked up pavement that would be too much to go out there and wand, then this is a mass crack treatment. In fact, the state of Arkansas uses that as their title, is rejuvenating mass crack treatment for this pavement preservation. The title explains exactly what this is designed to do. Probably another thing that we'll talk about here is that a scrub seal can be used later in the pavement life cycle than a chip seal should be used. And we'll explain what that kind of means. So what's the value that you get out of a scrub seal? Well, the value for your network is high. And that's because a scrub seal actually gives you another option to extend the pavement's life other than just going to a mill and fill. If you've got a budget and you were going to use all of that budget for scrub seal versus trying to go out and do something corrective, another corrective action like a mill and fill, then you're going to be able to treat more lane miles with the scrub than what you would be. So it really shouldn't be compared to, in value-wise, it really shouldn't be compared to like a chip seal. It really ought to be compared to what you would get out of a mill and fill because you're addressing the cracks that way. Scrub seals are fast. A good contractor that's up on his game, he can get miles done in a day. Traffic can usually be returned in just a couple of hours, so disruption is minimal. People who manage pavement networks like them. It makes decision makers happy because they can see results fairly quickly on the way that it has helped their network. So let's talk a little bit about how a scrub seal works. Basically, you're going to have that emulsion sprayed out and scrubbed into the pavement with your scrub broom. And whereas a chip seal is limited to a max crack width of about 1/4 of an inch, scrub seals can be used on larger cracks. And that's because you've got that broom being pulled behind that asphalt distributor with that wave. And it's that wave that gives you that volume of necessary emulsion to fill the crack up with. And if you don't have that wave, if somebody's just back there just dragging a broom, then you're really not getting what you're looking for. Now, Chris did an excellent job on talking about rejuvenators, and he's actually saved me a little bit of time. But it's important that you have that rejuvenator in there to give a new life to that cracked up pavement that's there. What a lot of people point out is that what you're really doing is you're softening the face of that crack so that that new emulsion that you put in there can really bond to it and seal up that crack that you have. Now, like a chip seal, the next thing that we have here is that you're going to drop in a layer of aggregate. That's important because it protects the that emulsion that you put down there from tires and stuff like that getting into it if it's just a standalone riding surface. But keep in mind that a lot of times scrub seals are often used as interlayers where they might be covered up with an overlay or a micro. And this is real important because you might not have to mill out a road if you're going to use a scrub seal on top of it. and it can help resist reflective cracking from coming back up to the surface. So that's some of the benefits that you get there. Here's an example of what a scrub seal versus a chip seal, what was done on a test project. They put a chip seal out and they put a scrub seal out to compare the two, and then they went out and took cores directly over a crack. And as you can see, the scrub seal actually filled up that crack so much that that core actually stayed together, whereas the chip seal didn't really get enough emulsion down in the crack to hold it together. So you can see that when you're sealing a crack like this, you're really going to reduce the amount of water that's going to be reaching into your road base, which is going to eventually really deteriorate the quality of your road. We've got some online training, and I thought I would show you a video here that will just kind of give you a better understanding of when to use a scrub seal and where it's going to fit into a good pavement network maintenance strategy.
The molecular structure of asphalt pavement creates a viscoelastic surface, which means it resists deformation under stress, but when it does deform, it returns to its original shape after the stress is removed. As asphalt pavement ages, its molecular structure changes, increasing the viscosity and reducing the elasticity. Short-term aging, indicated by rapid stiffening during production and while the mat is being laid, compacted, and cooled, is due primarily to volatilization, which describes how lighter molecules vaporize and escape into the atmosphere when subjected to high temperatures. After volatilization, the remaining molecules bond together, creating a stiffer molecular structure. The steam and fumes that pour out of the haul trucks and the paver during placement are actually the first indicators of this early phase of aging. Asphalt continues to stiffen over its entire 15 to 20-year service life, but the later stiffening is due to oxidation and molecular breakdown, which continually increases viscosity and reduces elasticity. This progressive hardening ultimately causes fatigue cracking, which allows moisture into the base and causes structural damage to the roadway. This graph, with time on the x-axis and viscosity on the y, shows how a typical asphalt pavement stiffens quickly early in its life and then gradually continues to harden over time. Looking at the asphalt aging process from the perspective of pavement deterioration, with pavement condition from good to poor instead of viscosity on the y-axis, here's what the curve looks like. About 2/3 of the way down the curve, there's a point of accelerated deterioration. This is where the pavement base begins to sustain structural damage. Above this point, routine maintenance is sufficient to prevent further deterioration. Below it, after moisture has penetrated into the base, costly structural rehabilitation or reconstruction is necessary. Windows of opportunity for maintenance treatments begin just a few years into the pavement life cycle, with fog seal, slurry seal, and microsurfacing near the top of the curve. A little further down, you have crack seal, ultra-thin overlay, cape seal, and chip seal. The window of opportunity for a scrub seal treatment is just above the point of accelerated deterioration, when the pavement is beginning to show significant signs of distress, but the base is still intact and able to carry the traffic load. One thing to notice is the steepness of the curve at this point. When pavement hits the point of accelerated deterioration, its condition worsens quickly because of significant oxidation and molecular breakdown. Just 1 or 2 years without a treatment will cost tens of thousands of dollars more further down on the curve. Understanding this dynamic is the basis for an optimized approach to road maintenance. For more detailed information about pavement deterioration and maintenance, go to roadresource.org.
Okay, so that brings us to our first best practice, and that is to identify just a good candidate. As he talked about in that window of opportunity in the pavement deterioration curve, using a scrub seal, there's usually 3 candidates that you can think about, and that's an optimum, average, and stopgap candidate. For an optimum candidate, what you're looking at is something that's going to be up near the top of that window. It's going to be a Pacer 6 or a PCI. Pacer and PCI are just pavement rating methodologies. Pacer stands for some pavement surface evaluation and rating, and PCI stands for pavement condition index. They provide a convenient way to quantify and analyze the surface condition of your road, and they can also help you prioritize your projects if you've got a pavement maintenance network. For an optimum candidate, you're going to fall somewhere in that selection, and if you do that, you can expect a life extension of about 8 years. This picture shows a typical optimum candidate. You may notice some rattling, some traffic wear. Longitudinal and traverse cracks are generally going to be less than a 1/2 inch wide, and you're going to start to see some of the first signs of block cracking. Now, for average candidates, that's going to be in that Pacer 4 to 5 range, a PCI above a 55, and you can expect about 5 years of life. With that, what you're looking at is going to be moderate to severe rattling. You're going to have probably multiple longitude and traverse cracks, some of which may be wider than a 1/2 inch. And then you're also going to have probably about 50% of the surface may have some block cracking and stuff. Now, sometimes in this PCI range, you're going to start to see some rutting. Applying a scrub seal to a rutted pavement is not recommended because if you do, you're likely to develop some bleeding in the area of that rutted wheel path. And then really your last candidate is a stopgap candidate. And it's going to be located around the 4 to 3 in the Pacer. And it's going to be anything under a PCI of about 40. This is where you're going to start to see structural damage of the road. And when you do that, a scrub seal here in this range is only going to last a year to maybe 3 years. Now, here's a picture of one that's getting down into that area. You don't really want to get into a habit of saving your scrub seals for this type of road because scrub seal is not designed to fix structural distresses. If you're going to be remilling a road like this or recycling or rebuilding it or something, then a scrub seal would be a convenient and cost-effective method here to maybe maintain that ride quality that you have and prevent further deterioration till you can get in there. But again, let me say, scrub seals are not designed to repair structural damage. They're a great mass crack treatment, but they're not going to be effective in repairing potholes or ruts or base failures. Let's compare a little bit of the value when looking at the service lives of each one of these candidates. Let's just assume that the national average for a center lane mile of putting down a scrub is about $35,000. So if you take in the optimum situation, if you take the service life of 8 years and divide it into 35,000, what you get is $4,375, which is your annual cost per year to have that treatment. But if you look at those other two columns, that average and stopgap, you can see that it might be $7,000 for an average and $12,000 to $35,000 for a stopgap measure. So what that tells you is picking that road at the right time, you can have up to 1.5 times more value than you would over an average road and up to 8 times more value over a stopgap candidate. So you see the value you get when you apply a scrub seal to the right road at the right time. After choosing the right candidate and understanding, what kind of life that you're going to get out of it, the next best practice that we need to talk about is writing a good spec. A good project spec is going to provide good, clear direction for every aspect of the scrub seal job, and it's just one of the easiest ways to ensure that you're going to have a successful project from the beginning to the end. A good spec is going to talk about materials, equipment, application or construction requirements, the quality control and measurement and payment. The materials and application part are there to make sure that the physical characteristics of that emulsion and that aggregate and their application rates all meet the construction requirements. Now, I cover 3 states for what I do, and not all of them require mixed designs within their spec, but I highly suggest one. The goal of a mixed design is to make sure that you get the right application rate of the emulsion and the aggregate to have enough emulsion to thoroughly seal all the cracks that are down there and still leave enough emulsion on the surface of that road to glue any rock down. The process is usually done by a qualified lab. It takes in more than what I can talk about in this presentation, but it's going to take into account things like the type of pavement that it's going on, the traffic volumes, the size and shape of your rock, a whole lot of stuff like that. I'm gonna put my email address up at the end. If anybody wants to have any information on that, I can get them some information on mixed designs. But a mixed design, what that does for you is it just gives you a starting point for success. It's not the end all be all. Understand that when you get out on a job site, the field conditions can change. So sometimes you need to be able to change that application rate that you come up with. One other thing I want to talk about right here is the measurement and payment that's on here. I don't have a lot of time to go in this. Generally, what people think about is just a way to get this project paid for. Measurement and payment can actually be set up in a way to induce a good to motivate a good behavior of the contractor. A lot of times people will pay for a job by the square yard, or they'll pay for it by ton and gallon. Both of those things have their pluses and minuses, and just know that, be willing to look at that, because sometimes you can set that contract up to make sure that the contractor doesn't put down too much rock, or will be willing to use more material when he needs to, things like that. You know, the real value of a spec is that it provides good, clear communication between the road agency, the design engineer, the contractor, and probably what I like to say is the most critical team player of this thing is the inspector. I have been doing this for a long time, and jobs that have inspection tend to have less problems than those that don't. It's good. It's just a good practice to have an inspector. That leads us to really kind of my next and last point that I'm going to talk about, or best practice that I'm going to talk about. There's a ton of best practices. In fact, we give best practice seminars to contractors, to inspectors and things. And sometimes those presentations can last 2 hours to talk about everything. But the last one I'm going to talk about today is just educate, educate, educate. Jobs where you have an educated contractor and an educated inspector seem to be go a whole lot more smoothly and have more success than those that don't. And one thing I want to point out about like inspectors is a lot of times those guys and girls are young. They have the least amount of experience, and they just don't have the confidence to ask questions or to stop a contractor when they feel like something's going on, especially if that contractor's been doing this for 40 years, longer than they've been alive or whatever. So educating those guys together is really a good process. The inspector has to have the knowledge of what the scrub seal process is, but to be successful, he needs some job site experience also to understand and recognize problems and help troubleshoot those things when they happen out there. I mean, this summer I was on a job that just really gives this as an example, because the contractor nor the inspector, now the inspector had a lot of job experience, but he didn't have any scrub experience. And we had about a 2-hour on-site best practice thing where we talked about broom setup, application rates. We talked really about everything you could think of. By the end of that day, that contractor was going smooth. He had a good production rate. The inspector, because he was able to ask questions and get comfortable, the plan design had set up for way too much quantity of rock and emulsion, and the inspector was confident enough to go in and say, hey, we got to pull these rates down to make this a good project. And education was just the key there. And I can say this is because that exact same contractor about 3 weeks later sent an entirely new crew with no experience to a job. And that job had an inspector who was new and didn't have any scrub seal experience, and it didn't go as well. The owner of that job is now cautiously waiting. He's not exactly thrilled with what it turned out. And there's a chance that come next spring, all the rock will have come off the road because the contractor, the inspectors didn't know to stop the contractor with some of the things that the contractor was doing, and the contractor just didn't know they were doing things wrong. Let's give you some pictures of what you can expect if you have problems. Here's a situation where the contractor was more worried about production than he was following the spec, and there was no inspector on the job. He actually did this job in the rain. All of the rock, as you can see over here on the side of this road, turned loose. Had there maybe been an inspector out there, maybe something like this wouldn't have happened. The next picture here is we actually offered this contractor an on-site best practice talk, and he refused it. And you can see some things where he didn't know how to pull his broom out, so it left a lot of streaking in areas. There were other times where his broom was not set up right, and it left some bleeding issues where gaps were in between his broom. Here's a situation where his broom was acting like a squeegee and it was making rock not hold and leaving on the side of the road here. So had he just taken advantage of that, then maybe this wouldn't happen. The problem is that this road is where the district engineer has to travel every day to go to and from work. The district engineer called me and immediately set up a best practice seminar for his inspectors. And then he gave them a pep talk not to fall asleep during that thing. So he was not happy with the results of this. And again, this could have been prevented had they just been willing to sit through some education. Here's a picture of his broom. You can see that he wasn't taking care of it. There's a lot of trash in it. That's the reason why it was acting like a squeegee out there, that these brooms were real hard. This was a different job, and it gives a situation where the inspector on this, when I told the inspector, he went out there and changed 1 or 2 brooms right in here, but he didn't do anything. And I informed the inspector, I said, if he uses this for this job, it's going to cause some problems. And the inspector told me that he was going to retire by the end of that week, and that really wasn't something he was too concerned about at the moment. So, and sure enough, this contractor had a lot of problems with this road, and part of it was because he was just allowed to use a broom that should have been corrected by the spec and by the contractor for doing that. Here's the last. I could go on and on and on, but here's the last picture I'm going to go with. And this is another example of a contractor who had zero experience. All they knew was that one guy was supposed to spray asphalt and pull it and drag that broom, and another guy was supposed to drop chips in it, and another guy, he was just out there to fuel everything. Now, they didn't communicate, because if they had, they would, and if they had sat through a training and education, they would know that this chip spreader was supposed to stay as close as possible to that asphalt distributor. What ended up happening was this road here stayed uncovered for about 40 minutes. And that is likely going to cause a problem. Hopefully not. Maybe it'll work, but we don't know. We won't know until next spring, maybe. But again, it would have been avoidable had those guys just had a little bit of education before this project started, not to do things like this. I just want to say thanks for letting me be a part of this. Like I said, best practices scrub seals seminar could go on for 2 hours if you covered everything. We give them to contractors and agencies every year. So if anybody has any more questions, jot down my email, send me an email. I can get you a link to some online training, or we can talk about doing some things in person. But just take away from this one that to start, really good practices are select the right road, have a good specification, and then just make sure all of your team is educated.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.